made of measurements, maps and scales, and a little bit of finance planning. All right. We look at question number 1 first. We see the instruments. We see instruments that are used to tell time here, but they are displaying time in 2 different formats, one being digital and analog. And down here we see what we call a speedometer, and we see thermometers on the right-hand side. Identify the 2 different types of clocks represented. We say we have one called the analog, and the second one is called the digital. Name the notations that can be used to differentiate the time of the day on the 12-hour system. So we shall use it's AM or PM. Write down the time. Write down the time in the evening on clock C in 24-hour system. So we come here, this is C. When you look at this, it's 11 minutes past 10. They are saying evening, so it's supposed to be PM. But the question wants you to express it in 24-hour system, which will be 22 hours, 11 minutes. And we continue and we shall say, identify the speed in miles per hour that is seen on the speedometer. The speedometer is this other item here that we are looking at. And when you want to tell that, actually it has already displayed here. You see 75. Also here it shows 75. So the answer is supposed to be 75 miles per hour. Write the temperature of 20 degrees Celsius in Fahrenheit. We shall use the temperature. We shall use the thermometer here. Look for 20. Which line does it correspond with? 80. It becomes 80 degrees Fahrenheit. All right, we go on and we say, we look at question number 1.2. An assembly plan for a set of side tables can be seen below. This assembly plan has no instructions. All right, you can look at the items that you need to assemble and steps to be followed. 1.2.1. Determine the total number of parts that must be used to make up all the tables. So these are the parts. Up here we have part type A. They are 3. Part type B, they are also 3. Part type C, they are also 3. Part type D, they are also 3. Then when you come down here, we're looking at the screws. We have 18, and the bolts we have 18. Okay. So here, remember we said it was 3 times 4 plus 18 plus 18, which gives us 48. Which gives us 48. This is 12. 12 plus 18, you get 30. 30 plus 18, 48. Identify the part of the table that will help to reinforce or support the table. Now, to reinforce, like to add more power, strength, it's this part here. This that you see here. So we shall come here and we find out it's what? D. Part D. We shall say part D. Then name the step of the assembly diagram which will secure the screws and small bolts. The step that will secure this here you are inserting them. They are not yet secure. 5, you are fastening. You're using what we call the Allen key. Yeah, this one here. You're making them secure. You're making them tight. So it will be part, saying part 5, step 5. All right, write a set of instructions or step 1 to step 3 of the assembly diagram. Let's go and see them nicely. You have to write what you see. Now in step one, we are seeing A being attached to B. So we shall say instruction 1, attach A to B. Instruction number 2, you might see, what do you see? We are attaching D onto step number 1. So attach part D to the set in instruction 1. Then 3, we shall say attach. What are you attaching? Now you're attaching C. Attach C. Attach part C to instruction set number 2. Probably you'll get your 3 marks. All right. It's all about your communication, or all about what you're writing. All right. How you write it. It's what matters most. So those were the steps. We come to question number 1.3. The floor plan of an apartment is shown below. This is an apartment, and we go on. Write down the compass direction of the bedroom from the kitchen. Now, the kitchen is right here, but look at the compass. The compass is facing that side. So that means this is what? East. So if you're from here going, because if this is your north, that means this is your east. So we shall say east. We shall say east. Then we shall say east. So we look at question number 1.3.2. Determine which rooms will receive the afternoon sun. Remember, the sun rises from the east, it sets in the west. So the afternoon, so we shall take rooms that are facing the west, because now the sun will come this other side in the afternoon. It will be this side. All right. So we have the kitchen and the living room. We have the kitchen and the living room. Calculate the width of the apartment. They want us to calculate the width of the apartment. Calculate the width of the apartment. So we are looking for the width of the apartment. We go to the apartment and we see width of the apartment, which is the shorter side. So we shall have it's this one here, this side, but it should also be the same as this other side here. Okay, we shall say we are going to add those values. 2,88 plus 1,2 plus 2,83, and the answer you got it as 6,91. 6,91. All right, determine the number of windows in the apartment. Let's count them. We have 1, 2, 3. These are sliding doors, they are not windows. So 3, we have 4. So there are 4 windows. We come down here, we say 4. Windows. Identify a design error in the plan. Now, a design error, where are mistakes? When you look at the bathroom, it has nothing like a window. The kitchen only has one window, but also here would have got another window here to bring in more light that you reduce on the electricity being used. Because now this seems like, since the source of light is one-sided, during day, it will be a little bit dark. So if you had two of them, even air circulation will be better. So the first error is no what? Windows in the bathroom. Then the other one, we have one window in the kitchen. One window in the kitchen. Question number 2. Shown below is the layout plan for a wedding venue. The wedding venue has a reception area and a hall where the wedding takes place. Reception area and a hall where the wedding takes place. So there we go. This is how it looks like. And they ask us, explain the term layout. A layout, this it could be a plan of how. A plan of how tables and chairs are organized. You can say organized or arranged. A layout, a plan of how the table and the chairs are organized. It's fine for the wedding. Identify the type of scale. When you look at this diagram here, this is the scale that we have. So you would have said it's either a line scale, or it qualifies to be a linear. It qualifies to be a linear scale. Measure the scale. Now, what they want you to do is for you to put your ruler here up to there. You tell us what have you got. When you measure the scale, I for one, I got 30 millimeters. And I measured this, and simply meaning they're asking you now, measure the scale. We shall have different answers according to our rulers. Then explain what the scale represents. So now they are telling us that you've got 30 millimeters. And means 30 millimeters on paper. 30 millimeters on paper represent here, the scale was ending at 5 meters, represents 5 meters. It represents 5 meters in real life. Determine the total number of people that the hall can sit. So simply meaning we shall only count the chairs. So apart from this one, it has 9 chairs, but the rest have 10. So we have 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So each table there, it has 10 chairs complete, apart from this one, which has 9. So we shall count that. Then in this table here, how many do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So here we have 12 So of the 13 tables, each carrying 10, you see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So in our counting, we shall say 13 times 10 plus the 12 plus the 9, which is 130 plus 22, which becomes 152. Sorry, this is 1, not 22. This is 21. And you get okay. 2.2. The layout plan shows that the number of round tables that can fit in the sitting area in the hall the number the layout plan shows the number of round tables that can fit in the sitting hall area in the hall. A wedding planner wants to confirm that the sitting area can accommodate all the tables shown below. So this is size. The length of the table, including chairs and spaces around the table. Determine the length of the table, including chairs and the space around the table in meters. They have told you it's 90. These are inches. Change them to centimeters. I've told you 1 inch is equivalent to 2 comma. So we shall change to centimeters. When we change to centimeters, 98,43 times 2,54. So we have 250,0122. These are centimeters. The answer is needed in meters. So we divide by 1,000. Sorry, 100, not 1,000. And the final answer comes 2,5 meters. All right, we go to the next question, which says, calculate the maximum number of tables that can fit in the sitting area. 5 marks. Now, here we go. They have told you the length of the dimensions of the sitting area. The length, it's 15 meters, and the width is 7 meters. So we shall find out on the long side, how many tables will they be? And on the short side, how many tables will they be? Now, how do we do that? Simply meaning we shall get the 15 divided by, remember we've just changed the diameter of the table, 2,5. So we shall do that. 15, 2,5 is you have 6. That means 6 tables on the long side. Then what about on the short side? On the short side, it will be 7,5 divided by 2,5. And you end up having 3. So, all in all, we have 3 times what? And the answer becomes 18 tables. 18 tables. I wanted to show you that. 5 marks. Well, first and foremost, you analyze that you're supposed to look for that. Then here you come with a conclusion. Question 2.3, a route map showing the direction to the wedding venue is shown on annexure A. The weather forecast is shown in table 1 in annexure B. Give the guest traveling on the N1 Johannesburg direction to the wedding venue. First and foremost, we need to know where is the wedding venue. The question that does not talk of the wedding venue at all. Let's go to the next chart. We see. Yeah, this is it, but we don't know the map showing the route to the wedding venue. When you look here, there's nothing to do with the wedding venue. So if a question comes like this and you can't understand it, please keep it aside. This is done. This one here. No direction to wedding venue. Determine the likelihood of it snowing. So we go to the we come to the weather chart here and we look for snow. So the chances of it snowing, it's 0. Likelihood, we say unlikely. Oh, it's impossible. Determine the probability of the percentage of it raining on a Saturday, the day of the wedding. Saturday, the day of the wedding. Of it raining. So we have 1. We have rain. And here we have this. So it's 2 out of 3 times 100. Which becomes 66.67. Don't forget the percentage sign. All right, that has brought us to the end of question number 2. Let's go to question number 3. Question number 3. The pool at the school needs a pool cover. A pool cover prevents people from falling into the pool and protects the pool from having dust and everything. All right. The diagram below shows the dimensions of the pool and the cover. The pool cover overlaps the pool by 1 meter all around. So this dark part here, it's 1 meter. Okay, here they're asking us, determine the perimeter of the pool cover. So we are outside now. Pool cover, this one here. So if the inside part is 24, what will be the pool cover? Because it can't be 30 up to. So we see that this side there's 1 meter, also this other side is 1 meter. So simply meaning the length of the pool cover is 26. All right, then we come. What about the width? It will be 14, straightforward. 14. But now, this is when you look at the complete one. What about this side here? So here there's a 10, which is okay. So you ask yourself, what about here? Since we said this is 26, from here up to there, it's 26. That means it's 4 remaining, and it will be 4 this side also. Then we've got from here to there, it's 4. What about from here up to there? Since this is 10, and when you add up, it is supposed to add up to 14. That means also this is 2. And down here, that's supposed to be 2. So we shall say the perimeter now. Perimeter will equal to 2 into 26 plus 14. These ones I'm putting them in here because they're going to repeat. There's a 26 up here. There's a 26 up here. There's a 14 here. There's a 14 this side. That's why I'm saying they're repeating. But then we have the 4, which is here, and here we have the 2, which is there, and here. So these have to be separate, and we shall say plus the 4 and plus the 8. The 4, these 2. The 8 is from here. So this simply meaning it's 2 times 40 plus. Oh yeah, we don't need to count this 2 because it's already repeated already. So we're only looking at these 4s that made 8. The answer is 80. Don't forget the units. Meters. Determine how many times the large. Determine how many times. Determine how many times. Determine how many times larger the area of the cover is compared to the area of the pool. So what we're going to do, we shall need to first and foremost, look for the area of the pool. Area of the pool. I would like it, let's come and use this diagram here. Remove these other ones here. I want you to understand the concept and follow the question. Definitely the cover has to be bigger than the pool. If the pool is bigger than the cover, then there's no use there. Allow me to use a certain color here. So this is the pool that we are looking at. What's its area? So its area, we shall say, area of the pool, it will be this times the 12. You see that? So here, the answer becomes 288. So this is the area. What about this one inside here? So we shall also add on the 8 times 4, which is 32. This is the area of the pool only. So here we go. We shall get the area, and we shall call it 320. 320. So these are meters squared. This is the area of the pool. Then let's look at the area of the cover. Area of the cover. So the area of the cover will be, remember the cover has a little bit a bigger distance. So it's 26 times 14. So we have it as 346 meters squared. Plus, also we look at this area here, which will be 10 times 4. Because it's this 10 here times the 4. Which is what? 40. So when you add everything here, you end up having 404 meters what? Squared. So we shall go and do now our question down there. So now, since we are looking for larger than, that means we shall get the area of the cover divided by the area of the pool, of which we've just seen how we got it. So we shall say 404 divided by 32, which is 1,26. All right, let's look at question number 3.2. So this one also, we are looking at the volume. Determine the total capacity of the pool. We use the following formula. Total capacity. The shallow end has 1 meter, and so we are going to do what? Because it's split into two. So since it's volume, allow me use the pool or the diagram where we are, and that you understand what we are dealing with. So they are saying if it's volume, we shall say L times B times what? So volume for the deep one is going to be 26 times 14. The deeper one is 2 meters high. So you get the volume there. So you end up having 720. These are meters what? Cubed. Put it aside. Then the shallow one, we can say it's 8 times 4 times 1, which is 32 meters also cube. And when you add them up, you get 7. Oh, sorry, this is supposed to be 12. And forgotten about this. Supposed to be 12 because you are looking at inside. So this one becomes 608 millimeters cubed. Hmm? 24 times 12 times 2. You have the answers 570 meters cubed. Then you're going to add them up, add this with. So the answer there became 60 meters cubed. All right, we go to the question number. We are done with the volume. Here they're telling you the chlorine is a chemical that's used to prevent bacteria and algae from forming in the swimming pool. For every 1,000 liters of pool water, 1.5 teaspoons of chlorine is required. So they ask, determine the number of liters of chlorine required to. So first and foremost, we've seen that we have the volume as, turn it into liters. So we have this much. But they said for every 1,000 liters, so we need to divide by 1,000 again. You have 1,5. 1,5. We need to find out, and we are getting the answer as. So this is it. These are the teaspoons. So each teaspoon is 5 mil. Multiply by 5, we end up having. These are mils. The question wants you to have liters. Divide by 1,000. Which is 4.56 liters. All right, we go to the other question. Determine the number of liters of water per minute required to fill the pool. Now remember, they have told you that it takes 9 gallons per minute. So in 1 minute, it has taken 9 gallons. So 9 gallons, we want it in liters. How many liters? So we shall multiply by 3,78541. The answer becomes determine the time taken in days to fill the pool. Round your answer to the nearest day. Now remember, the pool has this much water. You see that? Then in 1 minute, so we need to find out how many, so we need to divide it by remember, this is the number of minutes in a minute, so we are looking for the number of minutes here that we're looking for. And that means 60.800 divided by 34.07. So we have 70,800. These are minutes. So we divide them by number of minutes in a day. Find out how many days are they. Divide by 24 times 60. Which is approximately 13 days. Days. All right, let's look at question number 4. Question number 4. Here we have CMX fire pits for a living. A fire pit can be used for outdoor entertainment. The pit is made of metal shed. Okay. This is how it looks like in the picture, the side view, and the top view is this other one here. So they're asking us here, determine the area of the metal border. It's so simple. So what we're going to do is just, we are looking for what we call the shaded part. So the bigger circle minus the smaller circle. That's what we're going to do. So number 1, we have to look for the the diameter of the outer shape, sorry, the radius, because we're going to say area of the bigger circle. We shall need the radius of the bigger circle. Let's call it R. So it's going to be, and area of the smaller circle is going to be. So let's go down there and we find out. The radius, the big radius, will be 114 divided by 2, which is 57. These are centimeters. And the radius of the smaller part is going to be 100 divided by 2, which is 50 centimeters also. All right, the other one, 57, this one. So now we're good on analysis because you're going to get the area. To get the area of this part here, we need to subtract. We need to subtract them. Okay. So what we're going to do, we shall find the area of the bigger circle, which will become 3,142 times 57 squared. And we shall end up having a certain number there, which is approximately 10,000. We have 10,208, 36. Put it aside. These are centimeters squared. Then look for the area of the smaller circle also, which is pi times 50 squared. Remember, pi is the same as 3,142. Three comma 142 times 51 squared. So we end up having 7,855. So we need now to subtract these two. 10,208,33, sorry, 36,36 minus 7,855. So you end up having 2353, 36. Don't forget to put units. We look at question number 4.1.2. Sia claims that he needs 1,9 meters, 1,99 meters squared of metal sheet, including 10% for wastage, to make one fire pit. Verify the claim showing all calculations. Now, this is simply meaning, since we are looking at the material, we are looking for surface area. But remember, one side is open. One side is open for the cylinder. So we shall not have two. These two here won't be used because the pit is not covered. This part here has no cover. The cover is missing. You don't need any material here. So in actual sense, we shall use pi r squared plus 2 pi r h. This is the formula that we're going to use. Why am I using this? Because one side is open. It's not covered. Had it been covered, like the baked beans, then we would have used this other one here. This would be the formula to be used. Okay, let's continue. Let me hope you've understood. So, and actually they're saying you may use the formula, but this formula here does not consider what the opened end. Anyway, so we are saying we're going to use pi r squared, since it's only one bottle, one circle area, then plus 2 pi r h. When you simplify this, approximately it could be the same as pi r plus 2 h. and you factorize. I like it simple like this because to make your life simple. Instead of repeating things, you go once. Now, which radius are we going to use? I believe we shall use the one for the outer shape here. The outer, because now the material covers space here. Or if not, we can use the one for inner plus. Okay, yeah, we shall add on the metal border. All right, let's start and we say 3,142 times 50, open brackets, 50 plus 2 times the height. We've already seen this as 25. We have it as what? 25. So we got the answer there, 3,142 times 50, open brackets, 50 plus 2 times 25. So we end up having now this is area. Let's add on the one for the metal bar. So when you add on the one for metal bar, 2353,36, you get 18. You have 18,063,36. So we are going to increase, including the 10% for wastage. So that means we're going to increase this by 1,1. So you have the answer as 1,986,9,7. These are centimeters squared. First one is claiming meters, so we divide by 100 squared. And indeed we have 1,869, but we wanted to 2 decimal places, becomes 99 meters squared. So the claim is correct. The claim is correct. The claim is correct. 4.1.3. Sia wants to apply for 2 coats. Sia wants to apply 2 coats of paint to the fire pit to rust-proof it. Determine the number of liters of paint he must buy if 1 liter covers 5 meters squared. And now we've just seen it that he needs so here, because this is 1, the 1 liter covers 5 meters. This is less than, it's less than what? 5 meters squared. That means they will need 1 liter. They ask for 2 coats, okay. But still, I doubt that it will go beyond that. Anyway, let's see. Since he wants 2 coats, we shall say 1,99 times 2. So we end up by having 3,98 meters squared. So you're asking, well, I'm applying by 2 because of the 2 coats. They're asking to tell the number of liters. Okay, if 1 liter goes for 5 meters squared, and when you have 3,9 meters, what paint will you use? This simply means that we are going to divide by 5. The answer they became 0.796 liters, which becomes approximately what? 1 liter. All right, 4.2. Sia sells the fire pits at the local market. His expense for the month are as follows. We have rent. Rent we usually say it's fixed. Transportation. This could be fixed also. The metal costs. This is variable. It will depend on this. Then 1 liter of paint that costs this for only one. Also, this is variable. This means if you exceed 1, that means the money will go up. If you exceed 2, this money will go up. But even though you exceed 2, you exceed what? The rent won't change, the transportation won't change. All right. So you're asking us to create a total, create or write an equation to represent C as total expenses for the month. So remember, total expenses, we shall have what we call the fixed cost plus the variable cost. So to get the fixed cost, we already said rent is part of the fixed cost. So allow me to do this. It's 800 plus it's 650, which becomes 1,450. This is fixed. Then the variable for only one item, what will it be? For paint, it will be 199 plus. This is for 2. What about 1? So we shall take the divided by 2. Divided by 2. So we end up having 265. 265. 199 plus 265 equals to 464. So now the equation becomes 1 plus 464 times the number of what? Feet. Okay. Write down the break-even values. Remember, they've told us to use an extra C. An extra C is this one here. The break-even values, they're not that much clear. Check them here. You have to give us this other value here. Anyway, let's see. The break is beyond 2 and below approximately 3. But take note, we have 1, 2, 3, 4, 5. That means each line represents what? We have a difference of 2. So each line represents 0.4. Each line represents 0.4. So it's at 2.8. Then this other value here is going to be 1, 2, 3, 4, 5. So here the difference is 2,000. 2,000 divided by 5, you end up having 400. So each line represents 400. So here, I don't know which value is it. Should we say 2.8? So the break-even values would be 2.8 but mind you can't have a half a pit. So this will make it approximately 3. So for 3 pits, we spent that much, according to the graph. Okay, we continue the other question, which says, explain the meaning of break-even point in this concept. It's where income equals to the expense that Sia incurs when producing what? Producing the pits A shop orders 15 fire pits. Seller thinks he will make approximately 20,000 in profit. Verify the claim by showing all calculations. Number one, how do you get profit? This has to be new here. Profit will be the income minus the expense that you have incurred. So there are 15 pits, and they've told you for him to get the total cost, supposed to have to count like, remember the formula that we've just created and the number of pits. I'm looking for the cost. So it's 1 comma plus 4 comma 4 times 15. So the cost is this much. What about the income? Income, nowhere it's so talked of here. When you look at the scenario, the income is not talked of, but you can get it from the graph, whereby you ask yourself, at 0, you get 0. This is the income. But when there are 2, it gets 2,000. Look at that. When there are 4, it gets 4,000. Check, it's a nice line. When there are 6, it gets 6,000. So meaning each costs what? 1,000. It sells each 1,000. Because you get 6,000 divided by 6, you have 1,000. When you get the 2,000, the one that we saw here, is 2,000 here divided by 2, still get 1,000. That means it sells them 1,000. Okay. So we come back here to look for his income. Remember, they are 15. So it will be 15 times 1,000, whereby you get 15,000. So subtract now. 15,000 minus the cost, which was 8,410. So profit is so we conclude and say it is not valid. In other words, it's what? It's invalid. All right. That marks the end of question number 4. Look at question number 5 very fast. Maya is traveling from Johannesburg to airport to Rome. Johannesburg airport to Rome in Italy. Pilots measure the distance in nautic miles. Nautic mile is a unit of length in air, marine, and space travels. All right. Here we go. I've given you the conversion factors here in case you need to use them. Rome is 4,158 nautic miles away from Johannesburg. Calculate the distance in kilometers. What are you going to do? They have already told you that if you have a nautic, it equals to 1,15 miles. Or you have 4,000. So simply meaning you're going to get them multiply by 1,15, 1,151. Then the answer you get, those will be miles. 4,158 times 1,151. So you see, these are miles. But we want kilometers. That means we divide by 0,6215. And the answer became 7,700, 5 kilometers. The flight time from The flight time to Rome is 13 hours and 10 minutes. Determine the speed in kilometers per hour that the plane is traveling at. First and foremost, we need to change the minutes to hours because the distance is going to be kilometers per hour. So time used is going to be 13 plus 10 over 60. I'm changing minutes to hours. So I end up having the time as 13,17. These are hours. So the distance is already here. So speed will equal to distance. Speed equals distance over time. So we shall say 7700,5 divided by 13,17. And the final answer became 584. Rome has approximately a population of 22.9 million. That covers an area of 1,285.3 kilometers. So they're asking to determine the number of people per kilometer. So the number here per kilometer means we're dividing by the area. So this distance has to be, the number of people have to be numbers. So 2.9 million is the same as this much. So we divide by 5.3. So we have 2,256 people per kilometer square. All right, we look at question number 5.2. Measure the distance between Rome and Nepal and calculate the actual. So you're supposed to measure, you put the ruler here up to here. Now I got 0.5. I usually tell you to measure in millimeters because of those lines. Now, we've measured the distance, that's much. Then they want the actual distance. So that means we're going to use the scale. The scale tells us if you only have one unit on the map, you have 2 million in real life. So what are we going to do? We shall say 1 is to 2 million. That means I need to multiply with my measurements I put. What are they in real life? I need to cross multiply. 2 times 0.15. We get the answer as 10. So this one is in millimeters. You divide that by another million. You get the answer as, which is the actual distance. 5.2.2. A single flight costs 2,697 and a high-speed train trip costs 52 euros. Napel. Maya claims that the cost of the train is a third of the price of the flight ticket. First and foremost, we need to change this. Either we change this to, we need to change this to rands. Why are we changing to rands? Because what we're proving is already in rands. And yet I've put 1 rand, it's equivalent to this much. So I need to get 52 divided by this, which becomes 52 divided by 0.049. And the answer becomes 1,600. So this is the money for the ticket. Then we need to verse it with a third of the money for the flight. So 1 divided by 3 times 1,697. We have the answer as 899. The claim claims that the cost of the train is a third. No, it's not a third. So it's incorrect. It's incorrect. Then we come to the other one, 5.2.3. Maya is traveling 60.9 kilometers by car from Nepal to Amlifa Coast. The car has a petrol consumption of 6.6 liters per 100 kilometers. Petrol costs this much, which is €1.86. It's €1.865 per liter. Determine the total cost for the return trip. So this is just going. It's not a return. So you need to multiply by 2 first and foremost. We shall say that multiply by 2, you end up having 121.8. These are this is the distance covered. We need to find out how many liters shall we use. So we shall divide this by 100 and we multiply by 6.6. Why are we dividing by 100? We want to find out how many hundreds come out of this. So it's only 100 and it took 1.218 times 6.6. So you have 8. These are the number of liters or the amount of liters, so times 1.865. And the answer becomes €14.99. All right, we'll look at the last question, which is 5.2.4. Maya states that if she leaves Rome by high-speed train at 13:45, she will reach Alpha Coast by 7 p.m. Let's see. First and foremost, we should find out how much will she spend. So the train takes 75 minutes. This is 1 hour and 15 minutes. Then it continues for 45 minutes. You spend 1 hour and 15 minutes again. Then the cost at 90 minutes, which is 1 hour. So we need to add all those 1 hour. So we have 1 hour, 15 minutes. We have 45 minutes. We have 1 hour again and 15 minutes. Then we have 1 hour and 30 minutes. When you add everything, you end up having, 4 hours, 45 minutes. So these ones, we're going to add them onto the time that she will leave. We shall say 13:45 plus 4, 45. 45 plus 45, you get 90. So 90 of 90 will remain with 30, and you take the 60 aside to make a full hour. 1 plus 3, 4, 4 plus 4, 8. And the claim, or the statement is correct. The statement